new frontier. Humanity has always expanded its boundaries across oceans, across continents, and now across space. But colonizing the solar system isn't just about adventure. It's about survival, knowledge, and securing the future of our species. Hello and welcome to Astrobitica, your home for space news and information. Here we take the vast mysteries of the universe and turn them into stories you can understand, remember, and share. So before we begin, make sure to subscribe and tap that notification bell so you never miss a journey into the cosmos. Right now, all of us, every person who has ever lived, depend on a single planet. Earth is our cradle, but every cradle is eventually left behind. Sooner or later, if humanity wants to endure for thousands or even millions of years, we'll have to learn how to live beyond it. The question isn't, can we colonize the solar system? It's, where do we start? How do we survive? And why should we go at all? Our first steps, the moon. Our nearest neighbor, the moon, is the logical starting point. It's only about 3 days away by spacecraft, close enough for rescue or resupply, yet far enough to teach us what it means to live off Earth. NASA's Artemis program aims to return humans to the moon this decade and build a sustainable base at the lunar South Pole, where water ice hides in permanently shadowed craters. That ice can be mined, melted, and split into oxygen for breathing and hydrogen for rocket fuel. A lunar base would be more than a research outpost, though. It would be a test bed, a place to learn how to build habitats, grow food, and recycle air and water in an environment that offers no second chances. The moon is harsh. Wild temperature swings, no atmosphere, constant radiation. But its proximity makes it the perfect training ground for deeper space. Mars, the next frontier. Beyond the moon lies the true dream of colonization, Mars. It's far enough to feel like another world, with mountains taller than Everest, valleys deeper than the Grand Canyon, and polar caps of frozen water and carbon dioxide. A day on Mars lasts only 40 minutes longer than a day on Earth. It has seasons, sunsets, and gravity about 1/3 of what we're used to. Enough to walk, run, and perhaps even jump higher than you have ever done before. But Mars is also deadly. Its thin atmosphere offers no protection from radiation. There's no liquid water on the surface, and temperatures can drop to negative 100 degrees Celsius at night. Yet those same challenges make it a perfect long-term goal. Mars has resources, frozen water, minerals, and carbon dioxide that could be transformed into fuel and oxygen. If we learn to live off the land, to build with Martian soil, grow crops in controlled habitats, and extract what we need from local materials, a permanent human presence becomes possible. Companies like SpaceX envision fleets of reusable rockets carrying settlers and supplies, while NASA studies show how to produce oxygen directly from the Martian atmosphere using devices like MOXIE, tested on the Perseverance rover. It's no longer a question of imagination. It's a matter of engineering, economics, and will. Beyond Mars, the outer worlds. Once we master Mars, the entire solar system opens up. Asteroids may become the next frontier. Many are rich in metals like nickel, iron, and platinum, resources that could power entire industries in space. Mining them might sound like science fiction, but small-scale missions are already being tested. Further out lie moons of the giant planets, worlds like Europa, Ganymede, and Titan. Europa's subsurface ocean could hold more water than all of Earth's oceans combined. Titan has thick air and lakes of liquid methane. These places are too cold and distant for early colonization, but one day they may host research stations or automated outposts. Even the asteroid belt could become home to orbital colonies, rotating habitats that generate artificial gravity by spinning, as envisioned by physicist Gerard K. O'Neill. Such stations would support thousands of people, built from materials mined in space and powered by sunlight. The challenges. Colonizing the solar system will not be easy. Radiation outside Earth's magnetic field is relentless. Cosmic rays and solar storms can damage cells and DNA, making long-term health a major concern. Microgravity weakens bones and muscles, demanding artificial gravity or constant exercise. And then there's the psychological challenge. Isolation, distance, and delay. A radio message from Mars can take up to 22 minutes to reach Earth. In deep space, communication lag could stretch to hours. Every decision, every emergency will have to be handled by the people out there, not by mission control back home. Finally, there's the ethical question. Should we alter other worlds to make them habitable? Terraforming Mars, for example, would mean changing its atmosphere, temperature, and possibly destroying any native microbes that might exist. Colonization could transform us as much as it transformed the planets. Why it matters? Because exploration has always been a part of who we are. From crossing seas to climbing mountains, humans push boundaries, not because it's easy, but because it's how we learn, grow, and endure. Colonizing the solar system isn't just about survival, it's about progress. It's about creating new laboratories, industries, and opportunities beyond Earth, and ensuring that one day, no single catastrophe could end our story. Every habitat we build, every ship we launch, is a rehearsal for the far future, for the day when we may send humans beyond our star entirely. Right now, our species exists on one small planet, orbiting an ordinary star in one of the hundreds of billions of galaxies in the universe. But maybe not forever. The Moon, Mars, the asteroids, these are the first stepping stones into a wider universe. Each is a frontier waiting to be claimed not by conquest, but by curiosity, cooperation, and courage. If you learned something new today, give this video a thumbs up. Subscribe to Astrobitica and tap the bell so you never miss another journey through space and science. Until next time, keep looking up and stay curious.